Hi all, welcome to TutySpot. In this video, let's discuss about specification of tokens. First, let's talk about tokens. Usually, tokens are the smallest meaningful units of a programming language created by lexical analyzer from a stream of source code characters. They represent various elements like keywords, identifiers, operators, constants, and special characters which are then passed to the syntax analyzer. So let's discuss different types of tokens. We have multiple types of tokens. Some are keywords, identifiers, operators, punctuations, and many more. Keywords are reserved words for particular purposes and imply a special meaning to the compilers. These keywords must not be used for naming a variable or a function. Next, identifiers. These identifiers are the names given to the various components in a program like function name or variable name, etc. The main thing we need to remember is the keywords cannot be identifiers. Next, operators. These operators are the different symbols used to perform different operations in a programming language. Next, punctuations. These punctuations are the special symbols that helps to separate different code elements in a programming language. For example, let's consider int x is equal to 45. For example, let's consider int x is equal to 45. Here we have various tokens like keywords, identifiers, operators, and operators, where int is the keyword and x and 45 are identifiers and equal to is the operator. And also we have the punctuation. And next, specification of tokens. We have three specifications of tokens. First is the string, next is the language, and third one is regular expressions. So let's discuss about strings. Before that, let's know what the alphabet is. An alphabet is a finite set of symbols, like a set of 0, 1. It is a set of binary alphabets. And 0, 1, 2, 3, 4, 5, A, B, C, D, E, F. It is a set of hexadecimal alphabets. Like here, both numbers and letters both are present in the set. And small a to z to capital A to z. It is a set of English language alphabets. That is, both capital and small letters are included in this set. Any finite sequence of such alphabets is called a string. Suppose take string s is equal to a set of a, b as an example. Then the possible strings occurred are a, b, a, b, b, ba. And the length of the string is calculated by number of occurrences of symbols in the string. Suppose we have a string sample and it has 10 alphabets like numbers or letters. Then that string is written as sample is equal to 10. And if the length of the string is 0, that means it does not have any alphabets, then it is called as an empty string. And it is denoted by epsilon. Like if the string is sample and its length is 0, then it is denoted as sample is equal to 0. Next, operations on the string. We have 5 operations that we can perform on the string. Those are prefix, suffix, substring, sequence, and concatenation. Let's discuss about these operations. First is the prefix of the string. This string is obtained by removing 0 or more characters from the end of the string. Suppose we have a string s is equal to a, b, c. Then the possible prefixes can be epsilon if we remove all the characters, or a if we remove both b and c, and ab if we remove only c, or abc if we don't remove any. Whereas in proper prefix of a string, it should not be completely empty, and also we should not leave it like that without removing any character. So again consider the same example. If we remove c here, then the possible proper prefixes are a and ab. Second is the suffix of the string. It is also similar to the prefix, but here we have to remove characters from the beginning of the string. So take the same example, s is equal to a, b, c. Then possible suffixes can be epsilon and abc, and bc if we remove only a, and c if we remove both a and b. Proper suffix is obtained by removing at least one character. We have to remove from the beginning, and the possible Proper suffixes with the same example here are BC and C. So if we remove A, then the suffix is BC, and if we remove both A and B, then the suffix is C. Third is the substring. It will be obtained by removing any prefixes and suffixes of the string. Either any number of prefixes or suffixes can be removed, or the string can be the substring of itself too. Take the same example, S is equal to A, B, C. Then the possible substrings are epsilon, and if we remove A, then BC and C, or if we remove C, then A and AB, and if we remove both A and C, then B will be the possible substring. In the proper substring, we have to surely remove at least one prefix or suffix, and it should not be empty. So proper substring from the same example, S is equal to A, B, C. So the possibilities are A, AB, BC, C or B. Fourth is the subsequence. Here we can delete any alphabet from the string. They need not be in the consecutive positions. From the same example, S is equal to A, B, C. We can leave it without deleting anything, or we can empty it, or we can delete A or B or C as our wish. In the proper subsequence, the obtained string should not be epsilon, and surely we have to delete at least one alphabet. That means either A or B or C. Fifth is the concatenation. It is defined as the addition of two strings. Suppose if X and Y are the strings, then the concatenation of X and Y is denoted by XY, and the XY string is formed by appending Y to X. For example, if X is equal to COD and Y is equal to ING, then concatenating X and Y gives COD ING. And the second topic in specification of tokens is language. Language is any countable set of strings over some fixed alphabets. Usually language is a finite set of strings with some symbols or alphabets. Let's see different operations performed on language in lexical analysis phase. First is the union. Here in union, we combine two languages same as we perform on the sets. Suppose take the two languages L and S. If we perform union, then L union S will be equal to X such that X belongs to L or X belongs to S. Consider an example. L is equal to a set of A, B and S is equal to set of C, D. Then L union S gives A, B, C, D. Next is concatenation. Here we link the languages, means strings from one language will be linked to the strings of other language. Suppose take two languages L and S. If we perform concatenation, then L into S will be equal to XY, where X belongs to L and Y belongs to S. Suppose take an example. If L is equal to A, B and S is equal to C, D, then L into S is equal to AC and AD and BC and BD. Next is the clean closure. Clean closure of a language L is denoted by L star. That means it provides a set of all the strings that can be obtained by concatenating L 0 or more times. That means it can be denoted as L star is equal to union of I is running from 0 to infinity, L to the power of I. L star is equal to L to the power of 0 union, L to the power of 1 union, L to the power of 2 and so on. Suppose take an example. L is equal to a set of A. Then L to the power of 3 is equal to, we have to write A 3 times. Similarly, L to the power of 2 means we have to write A 2 times. L to the power of 0 means epsilon. Next is positive closure. It is same as clean closure, but the concatenation has to be done at least once. It is denoted as L plus. That means one or more occurrences of language L. So L plus is equal to union of I is running from 1 to infinity, L to the power of I. Means L plus can be L to the power of 1 union, L to the power of 2 union, L to the power of 3 and so on. Let's consider an example. L is equal to A, B. Then the positive closure L plus is equal to A, B, AA, BB. Like that, A and B can be written any number of times. And the third topic is specification of tokens in regular expressions. Regular expressions are the string of characters that define a setching pattern with the help of which we can form a language, and each regular expression represents a language L of R. A regular expression R can denote a language L of R, which can be built recursively over the smaller regular expression by following some rules. So let's see what symbols we have to use while writing regular expressions. First is the asterisk symbol. It is used to instruct the compiler that the symbol that preceded with asterisk symbol can be represented any number of times in the pattern. It can be 0 or more times. For example, let's consider an expression AB into C. Then it gives the following string as AC, ABC, ABBC, ABBBC likewise. That means P can be repeated any number of times. Either it can be 0 or 1 or 2 or many. Second is the plus symbol. It is same as previous asterisk symbol, but here the symbol has to be repeated at least once. See, for example, let's consider the same expression AB plus C. Instead of asterisk symbol, we are using plus here. Then it gives the string ABC, ABBC, ABBC likewise. That means this B has to be repeated at least one time. Third is the wildcard character. The dot symbol is also called as wildcard character. It can be used to replace it with another character. For example, consider A.C. That means this dot can be replaced with any other character like B or X or digit 1, etc. Fourth is the character class. Here multiple characters will be represented. Suppose A to Z denotes the regular expression A, B, C, D and so on up to Z. The following rules are used to define a regular expression over some alphabet, and the languages denoted by these regular expressions are: pi is a regular expression for the empty set, and epsilon is the regular expression for the null string. That means if epsilon is a regular expression that denotes a language L of E, then the language L of E has a set of strings epsilon, which means that this language has a single string which is the empty string. If A is a symbol in string, then A is a regular expression for the set A. That means set of A is here a language of L of A. That means the language has only one string of length and the string holds A in the first position. If R and S are two regular expressions, then union of two regular expressions is regular, means R by S denotes a language L of R union L of S. Concatenation of two regular expressions is regular. That means R dot S denotes the language L of R dot L of S. Clean closure of two regular expressions is regular. That means R to the power of asterisk symbol, that means star, denotes the language within the braces L of R, power of asterisk symbol. Then positive closure of two regular expressions is regular. Then R to the power of plus denotes the language L of R to the power plus. This is all about the specification of tokens. Thank you.